Okay, today we're going to be talking more about functions and their inverses and graphing those inverses. Okay, so the first thing we want to just keep practicing is evaluating functions. Okay, so for numbers 1 and 2, we see that it gives us a function, in this case p of x. This is our function here. And then we have a value, we have a value that it wants us to take and plug in to all the x's that we see. Okay, so now I have plugging in 4 for every x. This would be 4 squared minus 5 times 4. Okay, well then we can just evaluate this guy. 4 squared, remember follow PEMDAS here, order of operations. 4 squared is going to be 16. Okay, then we need to multiply before we subtract. Okay, remember, order of operations. This is going to give us 20, 5 times 4. Now we can subtract those two. 16 minus 20 gives us -4. Beautiful. Okay, number 2. Okay, so again, it's giving us a function, this time h of n. Okay, and then it's telling us what it wants us to plug in, of giving a value to that n spot. Okay, so now I have the absolute value of 3 times -9, used to be an n there, minus 3, that's all an absolute value, and then we have -1 on the end. Okay, so again, we treat these absolute values like parentheses, so we need to solve what's inside first. Okay, what's inside we need to multiply, so 3 times -9 is going to give me -27. Okay. Then I have the absolute value of -27 minus 3, and then we would subtract the 1. Okay, well then I have -27 minus 3, still in the absolute value, is going to be -30. Okay, but then we take the absolute value of -30. Remember, the absolute value is the distance from 0. So -30 is 30 distance from 0, so this just becomes +30. Absolute value of -30 is, excuse me, +30. 30 minus 1 gives me 29. Okay. Now, for number 3 and 4, again, it's giving us two functions here, and then it's telling us what we were going to perform an indicated operation with those two functions. Okay, so my first function, f of x, is 3x minus 1. My next function, g of x, 2x minus 5. And it wants us to add these two functions, f plus g of x. Okay, well that just means we're going to take our two functions. First I'll take f of x, and I'm going to add it to my g of x. Okay, remember when we're adding binomials or polynomials, we look at the sign in the middle. The addition sign means we keep the signs the same. Okay, so this just becomes 3x minus 1 plus 2x minus 5. Now all we need is to combine like terms. Okay, so I have 3x I can combine with 2x. 3x plus 2x gives me 5x. -1 minus 5 more gives me -6. So my final expression are 5x minus 6. Okay. Number 4, so we have f of a, 2a, and g of a, 2a cubed minus 3a squared. And it's wanting us to multiply these two, so f times g of a. Okay, so this is going to be, we'll take f, 2a, and it wants us to multiply, so we'll just stick it right next to g of a, 2a cubed minus 3a squared. Okay, well, now we just need to distribute. We're multiplying these guys so that 2a on the outside multiplies to everything inside. 2a times 2a cubed, 2 times 2 gives me 4. A times a cubed is a to the 4th. 2a times -3a squared, well, 2 times -3, -6. A times a squared, a cubed. Okay, and because 1 is an a to the 4th and 1 is a cubed, we cannot combine those or simplify that down anymore. So there's our final answer. Awesome. Okay, so that was just a quick review on evaluating functions, performing operations given those functions. So now what we're going to do is work on graphing these functions. It says sketch the graph of each line, then graph its inverse function. Okay, and let's see, number 5 and 6, I actually made a mistake here. I wanted it to be in slope-intercept form. No worries, right now it's in standard form. I want it to be in slope-intercept form, which means we want to solve for y. We want to get it to be y equals. Okay, remember y equals mx plus b is our slope-intercept form. Okay, well, let's go ahead. I'm just going to rewrite this over here so we can start solving it. 9x plus 2y equals 8. I want y to be by itself. So the first piece I need to move is this 9x. I do that by opposite. So the opposite of positive 9x is negative 9x, or subtract 9x. So now I have 2y equals, I like putting the term with the x in front. So negative 9x plus the 8 that was already over there. Okay, last step, to get y by itself, we divide by 2 to each term. So now I have y equals negative 9 over 2x, and 8 divided by 2 is positive 4. Okay, so now that it's in slope-intercept form, we are then going to identify the slope and the y-intercept in order to graph this guy. Well, my slope is always in front of the x, so negative 9 over 2. Y-intercept, positive 4. Okay, and remember that our positive 4 is always our starting point. That is a point on the graph. Okay, so we always start with that positive 4. So we're going to find positive 4 on our y-axis, put a point. Okay, and our slope is negative 9 over 2. Remember, rise over run. Well, it wants us to go down because it's negative. So from positive 4, we're going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And over 2. 1, 2. Okay, and there is our first line. Okay, so that's the function for the original, or the graph for the original function. Okay, so in order to graph its inverse, okay, we talked about this a little last time. With the inverse, we have our original coordinate points listed as x comma y. All we need to do is switch them. For example, let's look at our coordinate points. This coordinate point is 0, 4. And this coordinate point is 2, negative 5. Okay, well, in order to graph the inverse, we literally switch these guys. So this point is going to switch from 0 to 4 to 4, 0, which is right there. 4, 0. Switched. This guy is going to switch from negative 5 to negative 5, 2, which is going to be right, negative 5, up 2, 2, right there. And then you connect those two lines, and the red line is the inverse of that original function. And there we go. Our purple is our original function. Take those coordinate points, switch them, and that's our inverse. Okay, so let's do that again on number 6. Okay, so the first thing I want to do is I want to take this equation from standard form to slope-intercept form. So I'm just going to go ahead and rewrite it over here so I have some room. X plus 5y equals negative 25. Remember, we're trying to get that y by itself. So the first thing I need to move or get rid of is that positive x. Well, the opposite of positive x is negative x. So now I have 5y equals, remember, I like putting the x first. That's just usually how it's written in slope-intercept form. Negative x minus 25. That was already over there. Okay, and the last thing to get y by itself, opposite of times by 5, is divide by 5, everything on that side. So now I have y equals, I'm going to rewrite this negative x over 5, just so it's a little easier to see with our slope, negative 1 over 5x. Negative 25 divided by positive 5 is negative 5. Okay, so now that that is in slope-intercept form, we have our slope, we have our y-intercept. Our slope is always right in front of the x, so negative 1/5 or 1/5. Y-intercept, negative 5. Okay, our y-intercept is our starting point, so find negative 5 on your y-axis. That's going to be right there. Then we're going to use our slope to count. So this one wants us to go down 1, because it's negative, over 5. 1, 2, 3, 4, 5. Okay, we can connect those 2 points. Okay, and that is the graph for our original function. Now remember, in order to graph the inverse, we just take the coordinate points and we switch them. So this coordinate point is our y-intercept, 0, negative 5. That coordinate point is 5 down to negative 6, so positive 5 comma negative 6. All we have to do is switch these to graph the inverse. So now I have, instead of 0 comma negative 5, it's going to be negative 5 comma 0. Just going to be right there. And instead of 5 comma negative 6, it's going to be negative 6 comma 5. So find negative 6 comma 5. And there we go. There's our inverse function. So this one turned into negative 5 comma 0. This one turned into negative 6 comma 5. Literally just switched those coordinate points. All right. Okay, let's go to graphing quadratics and their inverses. Okay, so these two quadratics are written in standard form. Okay, so remember, standard form of a quadratic is y equals ax squared plus bx plus c. So that's going to help us find our a, b, and c. Okay, well, I know my a is the coefficient of 1, my b is negative 4, my c is 3. Okay, and this helps us out because in order to find the vertex of this quadratic function, which we have to find first, we have to find the x part of our vertex, which is negative b divided by 2 times a. Okay, so we can go ahead and plug in what we know. X is equal to negative b over 2 times a. Okay, well, my b is negative 4. Plug that into the b spot. A is 1. Double negative on top turns to a positive. Divided by 2 times 1 is just 2. So we have for our vertex, or the x-coordinate of our vertex, 4 divided by 2 is just 2. We still need the y part. Okay, so in order to find the y part, we just take our x and plug it into where we have x's. So now I have y is equal to x squared minus 4 times x plus 3. Take your x, plug it into the x spot. Okay, and remember, and you can just punch this whole thing into a calculator as long as you include the parentheses. If you don't include the parentheses, your calculator might give you a different answer because of order of operations. Parentheses 2 parentheses squared minus 4 parentheses 2 parentheses plus 3, and I get a y coordinate of negative 1. So y equaled negative 1. Okay, so now I have my vertex. Okay, so again, this is the vertex. So we'll go ahead and graph that. So it's 2, negative 1, so find positive 2 for your x, negative 1 for your y. My a is positive 1, which means we can just use our pattern, up 1 over 1, up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. Okay, so this is our original, or the graph for our original function. Okay, and now what we need to do to graph its inverse is identify the coordinate points and just switch them. So again, our vertex 2, negative 1, this coordinate point is 3, 0. That coordinate point is 1, 0. That coordinate point is 0, 3. And that coordinate point is 4, 3. Okay, and we might not graph all of these guys, but let's go ahead and graph the inverse. Okay, so let's switch them. Instead of 2, negative 1, it's going to be negative 1, 2. negative 1, 2. Instead of 1, comma 0, it is now 0, 1. Okay, instead of 0, 3, it is 3, 0. And let's see, I've done those guys. Instead of 0, comma 3, it is, wait, I just did that one. Instead of 3, comma 0, it's now 0, comma 3. There we go, getting a little turned around. And instead of 4, comma 3, it is 3, comma 4. And then we connect those guys, and it looks now like a sideways U, which is the inverse. Okay, a little weird. The only thing we did differently was we switched the coordinate points. Okay, so let's try that again. Okay, so the first thing we need to do, identify A, B, and C so that we can plug it in to find our vertex. So x is equal to negative b over 2 times a. Okay, well my b in this case is negative 4, a is positive 1. Again, double negative turns into a positive. 2 times 1 is just 2. 4 divided by 2 is 2. So the x part of our vertex is positive 2. In order to find the y part of our vertex, we take it and we plug it into our x spot. So now we have y equals x squared minus 4 times x plus 2. Okay, in my x spots are my 2's. Just punch this directly into a calculator. Just make sure it looks the same. So now I have parentheses 2 parentheses squared minus 4 parentheses 2 parentheses plus 2. And I get a coordinate point of negative 2 for my y. Okay, so my vertex for this guy is 2, comma negative 2, so find positive 2, then go down to negative 2. Our a is positive 1, so just use our pattern again, our trick, up 1 over 1, up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. Okay, there is the graph for our original function. Okay, let's just put our coordinate points so we can switch them. This one is our vertex of 2, negative 2. This one is 3, negative 1. This one's 1, negative 1. This one is 4, comma 2. And this one is 0, comma 2. Okay, so I'm going to go in this order just so I can keep track of it and switch these guys. So instead of 0, comma 2, it becomes 2, comma 0. Instead of 1, comma negative 1, it becomes negative 1, comma 1. Instead of 2, negative 2, it becomes negative 2, up 2, and that's going to go off the graph, so we won't even worry about that one. Instead of 3, comma negative 1, this is going to become negative 1, comma 3, up there. And instead of 4, comma 2, it is 2, comma 4, which again is going to go off our graph. So actually, like our vertex would be over here. So we actually don't even see the whole u of this guy. It doesn't fit on the graph. Sorry about that. But that is our inverse. It would go off the graph a little bit like that. Okay. Alrighty. We're doing the same thing, graphing quadratics and their inverses, except these guys are written in vertex form. Okay, remember that vertex form is y equals a parentheses x minus h squared plus k. Okay, where our vertex is negative h comma k. Okay, this one's a lot easier than just solving for the vertex. Okay, so we change the sign on our h. So our vertex for this guy, change the sign on our h. So actually, let's go ahead and identify a, h, and k. A is that invisible 1, h is on the inside, k is on the outside. So for our vertex, change the sign on your h. So instead of negative 2, it's positive 2. Keep the sign on the k, positive 4. Okay, so now we have our vertex, a lot faster, a lot easier than in standard form. Okay, let's place that on our graph. So 2, comma 4. A is positive, so up 1 over 1, up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. Remember, it's just that little trick. And there's our graph for our original function. Okay, so now to do the inverse, we just identify these coordinate points. So this was 2, 4. This is 3 up 5, so 3, 5. This is 1 up 5, 1, 5. This is 4 up 8. Some of these might not be on the graph on our inverse, that's okay. And this is 0, 8. Okay, so now we just flip these coordinate points. So let's start over here. So instead of 0, 8, it's going to be 8, 0. That would be over here off our graph. Instead of 1, 5, it's 5, 1. That one's on our graph, 5, 1. Instead of 2, 4, it's going to be 4, 2, so 4, 2. Instead of 3, 5, 5 up 3, right there. And instead of 4, 8, it would be 8 up 4, which is, again, is our off our graph. So our inverse is actually right there. Beautiful. Okay, let's do that one more time. So again, this guy's in vertex form, so we have A, H, K. So my vertex, remember you switch the sign on the H, keep the sign on the K, so H instead of -2 would be +2. And we keep the sign on the K, so -4. Okay, so let's go ahead and graph this guy. 2, down to -4. Okay, our A is 1, so we can just go up 1 over 1 on both sides, up 1, 2, 3 over 1 on both sides. There is our graph for our original function. Let's identify our coordinate points so we can go ahead and flip them. This one is 2, -4. This one's 3, -3. 1, -3. 4, 0. And 0, 0. Okay, now let's flip them. 0, 0 would just stay 0, 0, so that's a point. Instead of 1, -3, it's going to be -3, 1, which is going to be over here off our graph. Instead of 2, -4, it's going to be -4, 2, which again is off our graph. Sorry about that. Instead of 3, -3, it'll be -3 up 3. Again is off our graph. And instead of, oh my gosh, this whole thing is off our graph. So this is actually going to look something like that. The only point we had was that 0, 0. It's a little off our graph. But remember, just take the coordinate points and literally flip them. Okay, there you go.